Hello, everyone. Thank you for joining us today in the workshop, Smart Manufacturing Workshop. I'm Khalid Tantawi. I am the principal investigator of the project and project manager. So in this module, we're going to talk about the Arduino programming using the CoDrones that you received. So first, let's talk about computer programming generally. So programming languages can be classified into 4 or 5 generations. The first generation of computer programming uses machine code. So it's called actually machine code and uses actually punch cards to program. That was back in the 1950s when they first invented actually computers. As you see here, for example, this picture here shows actually a program. You see here how big it is. It's actually stacks of punch cards like this, where they have to punch zeros and ones. And as you can imagine, it's going to be very, very time consuming. It's going to be, it's going to contain a lot of errors because they have to type every zero and every one. And as you see, it needs a large amount of storage, physical storage for storing a very small amount of data. So that was the first generation. The second generation is assembly language. So assembly language actually corresponds one-to-one, line-to-line to machine code. It's actually the fastest way of programming. Let's say, I'm sorry, not the way of programming, but the fastest way of executing a program. So if you have, for example, a program, you need to program something, and real time is actually a concern for you, then the fastest and the most optimal way to do the program is actually an assembly language. However, it's actually the most difficult to program with assembly language, given that no one actually programs in machine code, of course. But the most difficult of all the available programming languages is with assembly language, because as I said, it has to correspond line to machine code. So for that reason, as time progresses, new higher level languages came up. So this was a second generation or intermediate level programming. Then there's the high level programming or third generation programming languages. These are most of the programming languages that you know, like C++, C language, Java, Visual Basic, MATLAB. All of them belong to this level of computer programming. Then there's actually higher level of computer programming where you have actually visual. So you have visual blocks that you can move around without having to type any codes. And they have pre-programmed codes in them and procedures that they will execute. So as you go higher in the level, the language becomes more complex. So it becomes more complex and less optimized. So the higher the level you go, the optimization level becomes lower and lower. And at some point, it becomes actually, if you're concerned about real-time execution, then it becomes too slow for you to execute in real time if you go to very high-level languages. So this is actually, let's say, the payback. Easier programming, but less optimization. Now, Arduino, so the Arduino boards basically are usually programmed in C++. So C++ or Python or other probably other languages. In this here in this workshop, we're going to see C++ programming. So now these higher level languages, the third and the fourth generation languages, they always come with a software that is called compiler. So the compiler actually is like a translator. It translates you. It allows you to let's say write in that language, but then it translates the code to assembly language. So everything eventually will go to an assembly language format. Then there's an assembler software that basically converts. It's a line-to-line conversion from assembly language to machine code. So let's talk about computer architectures generally. So generally, a computer will have the following units. There's going to be an input unit. For example, a push button. A push button is an input unit. A keyboard for more complex computers. Sensors or anything else, anything that gives you, that inputs data, gives data to the computer is an input unit. There's the CPU, the central processing unit. So this one is the one that does the processing for you. It contains, for example, the arithmetic logic unit, ALU, for instance. It also contains registers or memory. Registers are a very fast form of memory, but very, very small. Then there's the memory unit. Of course, the memory unit, there's different types of memory. For example, there's flash memory. There's, for instance, the RAM, random access memory, whether it was static or dynamic. And finally, there's the output units, such as, for example, an 8-segment display, an LED, for example, an LCD screen, or anything that outputs the processed information for you. Now, before we actually continue, let's also talk about something very important, which is microcontrollers and microprocessors. So the board that you have is based on Arduino. The drone is based on the CoDrone is based on Arduino boards. Now, the Arduino boards actually, for example, this one here is actually it's a clone of Arduino. These are very common, to find Arduino clones. Like, for example, the ILO group, for instance, it's actually a clone of the Arduino Uno, for example, and they are as good as the Arduinos actually, and very cheap. So, these boards actually contain a microcontroller. Okay, this unit here that you see is a microcontroller. And these microcontrollers, you can actually purchase them if you don't want to buy a board, but you can actually purchase the microcontroller itself. And it comes like a chip, like this. Like, for instance, this here is the PIC16F microcontroller by Microchip. So these microcontrollers, actually, they are computers. They actually contain all the elements of a computer. They contain a CPU, central processing unit. They contain memory. They have the system bus, input-output ports, and some other support devices, like, for example, digital to analog converters. So let's talk about the difference between a CPU, a microprocessor and a microcontroller. The microprocessor chip is like the one, for example, you have in your desktop computer, or the one in your laptop computer. Now, these chips, the microprocessor only does computing. Okay, it only does computing. You have to provide with it memory. You have to provide with it everything else, the system bus and everything else. So a microprocessor is built for speed. Its main purpose is speed. So it's going to be very powerful. It's going to be, it has a lot of very strong computational capabilities. The microcontroller contains a microprocessor unit in it, in the chip, built in with memory, with everything that you need, as you see over here. So microcontroller actually is built for achieving single tasks in real time. As long as it can achieve small tasks for you in real time, then it actually did its purpose. So this is the difference between the two. So a microcontroller is designed to provide a microscale integrated computing system, such as an embedded system, and while a microprocessor is designed for speed. Some examples of microcontrollers, like the example that I showed you, the Microchip PIC16F microcontroller. For example, the Motorola 68HC11, the Atmel microcontrollers also. By the way, Atmel was purchased. Actually, Atmel is now actually owned by Microchip. So on the other hand, microprocessors, there's also different types. For example, there's Intel, Pentium, for example, AMD, and Motorola 6800. So very popular microprocessors. Common types of Arduino boards. So now the Arduino board itself. So this here So the drone, the CoDrone actually contains an Arduino, one of the Arduino boards. And, so the Arduino board, there's actually different types. There's, for example, the Arduino Uno. For instance, the Arduino Uno uses the Atmel Atmega 328P microcontroller. So the board itself actually contains an Atmel microcontroller. Okay. Now again, Atmel actually was recently in 2016. It was actually owned. It was acquired by Microchip. So this one, for example, the Arduino one is very commonly used, and it has a clock speed. The microcontroller that it has a clock speed of 16 megahertz, and an SRAM, the random access memory, is 2 kilobytes, a flash memory of 32 kilobytes. It has 14 digital input/output. So as you see, it's very small compared to the speed of, for example, the processor that you have in your laptop, for instance. This is 16 megahertz. In your laptop, you can have actually, for example, 2 or 3 gigahertz. But you see, this one actually can achieve for you small tasks in real time. All right, the Arduino Uno. The Arduino Mega, for example, has 54 digital IOs. Its flash memory is 256 kilobytes compared to 32 kilobytes for the Arduino Uno. And the clock speed is the same, 16 megahertz. But as you see, it has enlarged RAM and flash and more input/output pins for you to use. So, so there actually, if you so these here, by the way, you can actually purchase many educational boards. Like, for example, here, like I said, this here is by Microchip. It costs like in the range of $150 to $200. And this uses a PIC16F microcontroller by Microchip, for example. This actually uses assembly language. So you need to, this for people who want to learn assembly language, this is actually a good board to use. Now, there's also clones, like I said, for Arduino. Like, for example, there's here, this kit here, a very, very good kit. Actually, it's the Elego. This is the Elego kit. It runs at like $30 or $40, and it contains, it actually teaches two things. It teaches actually programming the Arduino boards, in addition to electrical circuits. Like can connect to your electrical circuit here with different sensors and actuators, and run programs. The one that we have here, so the CoDrone kit that we're going to use. So it actually does not, let's say, does not teach on electrical circuits, but it's on programming. Okay, so it has actually, let's say, it has an enhanced programming capability. As we will see later, there's 3 ways of programming the kit. So now let's talk about the drone, the CoDrone. So the CoDrone, let's talk about the physical features. So it's actually designed, it has the quad rotor design. This is called the quad rotor design. As you see here, this is actually a simple design. It's usually used for small drones like this, small size drones. You use actually quad rotors because it's stable. It's very stable. Now, flight range 160 feet. The dimensions 133 millimeters by 133 millimeters, and has a weight of 37 grams. So now let's look at the propellers. So the propellers here we have, so they are directional propellers. In other words, if you look at the propellers carefully, for example, you will see here that these actually are not the same shape. You see this here. So each propeller, so there's a reason for that, actually, is for stability, of course. So this propeller here has to rotate in the clockwise direction. So it has to rotate clockwise direction. And as you see here, so the thrust so this here, for example, so in other words, let's say this here is, let's say, left-handed. Okay, so it rotates in this direction, and the thrust force, is going to be upwards, and there's going to be also, in addition to that, there's going to be a moment. Okay, so there's going to be a bending moment or torque that is going to be that is going to generate on the body of the drone. Now, for that reason, because of that moment that is generating, it has to be counteracted by this one over here. Okay, so the same thing. This here is right-handed, so it's going to generate the thrust upwards, but it's going to rotate in this direction. Okay, so in other words, they're going to counter each other's moment. All right. The same thing here. So this one here is going to be left-handed. So here we have, like in this direction, this is going to be left-handed, like this. And this over here, so these two here are going to be left-handed. These two are going to be right-handed. Okay. All right. So right, and here we have left. And this is how we actually cancel the torque that is caused by the spinning motors. If you don't cancel the torque, then what's going to happen is going to be spinning. Okay. For example, in helicopters, for example, you have actually in the back, in the tail, you have a rotor that cancels the spinning that is caused by the main rotor. Okay, by the lift rotor. So these are directional propellers. So that's why you have to match the propeller with the direction of the propeller guard as in the picture. So if you look at it actually here, you will see there's an arrow. There's an arrow here that indicates for you how does it rotate. And the rotation has to, for simplicity, you can just look at it. It has to match the guard that is on it. Make sure that no hair or fibers are tangled in the propellers. Look at this picture here, by the way. So this was the first helicopter to fly successfully up to 6 feet, using a 170 horsepower engine for less than 2 minutes. That was in 1923. I found this picture in the Library of Congress, and I thought it's good to include here. So this was the first, let's say, the first quad rotor that ever flew, 1923, 6 feet. All right. Let's look at other features of the CoDrone. Onboard sensors, a gyroscope. Well, a gyroscope is needed always for the autopiloting of the drone. A gyroscope, 3 axes, of course, used to maintain reference during the navigation. So accelerometers. So accelerometers actually they're used to sense force. The reason why is because it uses Newton's second law, force equals to mass multiplied by acceleration. You know the acceleration, so you know, and you know the mass, so you can tell the force, right? By the way, they are also used in advanced programming. You can actually use them to get several things, like for instance, you can actually get from them the speeds, of course, and positions. So you can get the position and the speed from the accelerometers. The gyroscope also helps with that. So these are actually used in autopilot programs that use different methods, like for instance, H2 method or different other methods in advanced control systems. Barometer measures atmospheric pressure to assist in altitude control. Of course, now all of these are used to help. They're used actually to help stabilize the drone. Other sensors, IR sensors, detect motion inputs. Optical. So we have some optical sensors, by the way. This cannot fly in the dark, by the way. The reason why is because it uses an optical sensor to detect the ground, and based on the ground, it can stabilize itself. So if the room is dimly lit, the drone will have a trouble telling if it is steady or not. Electrical characteristics. So when you actually buy the box, it comes like this. So this is the box, and if you open it here, you will see. So this is going to be this is the battery. It's a lithium-ion battery, okay, or lithium polymer battery. So this battery has 3.7 volts maximum voltage, 300 milliamp hour its capacity, 1.1 watt hours. It can generate 1.1 watts for 1 hour. So this battery, it can actually run for hundreds of cycles, but it can maintain the drone in the air for 8 minutes. So of course, just like all other lithium-ion batteries, you should never puncture the battery. It should never be punctured. You should never get it wet. And it's recommended that for long storage durations to store it at about 50% charge, not fully charged, not drained, but at 50% charge. Of course, the DC motors are forward, reverse, and speed control. You can control the forward, reverse, and speed control. The drone actually uses Bluetooth 4.0 for communication. So, by the way, these are the look at the rotors, by the way. So these are the directional rotors, as you see here. So you cannot just, if you want to replace a rotor, you cannot just replace any rotor, anywhere. You have to pay attention to the direction. Okay, as you see here, if you look at it carefully, you will see one of them, two of them are right-handed, the other two are left-handed. So these are the electrical features. Let's look at other features of the kit. So customizable, of course, customizable controller. It has additional control pins if needed, easily removable and replaceable parts, programmable onboard LEDs. In addition to the CoDrone itself, you can actually program the LEDs. Arduino IDE integrated development environment with online lessons and support. So this here, this kit comes with the manufacturer actually has lessons, advanced and basic and intermediate lessons for really all classes that are available. Again, so this actually is used for programming only, teaching on programming and not on programming with electrical circuits. And for that reason, as you see, it has actually advanced, let's say, advanced programming lessons and 3 different environments of programming. You can use Arduino, you can use Python, or you can use even a block form of program, which is a higher level, of course, a higher level language. So it has other, you can look at these features here. So 7 digital IR sensors, 3 analog IR sensors, and for DC motor ports, 5 analog and 5 digital pins, and a buzzer and LEDs. The capabilities, so self-stabilization, altitude hold, Bluetooth smartphone control. You can actually download an app and control it over by your smartphone. Sensor data feedback. It can be programmed, like I mentioned before, using 3 different environments. You can use blocks. This is probably a favorite for, let's say, kids in the middle school, in the elementary school. They can use blocks to program it. Arduino programming and Python programming. Let's say Arduino mostly for, let's say, high school level and entry-level college students. Python programming for advanced, let's say, mostly, let's say, college level programming. This is a screenshot of the Blockly. So this way of programming, in which you actually just drag blocks and connect them, and then voila, you have actually a program running. Helpful links, and this is where we should actually do the next step. You can go to these links, and each one of them will have lessons actually in all levels: beginner, intermediate, and advanced level programming in any of these three programming environments. If you, for example, like I mentioned, usually middle schools will like to use, for example, blocks, the block way of programming. High schools and colleges like to use Arduino and Python. Now, something actually that is important is to assemble it. So when it comes unassembled, it comes unassembled, and you will need to assemble it. So I'll actually put this here for you, where you can put the boards, connect the boards to each other, and do the connections. There's also a link, by the way, here on YouTube. So this is on YouTube, where you can go to the video and follow step by step. It's very, very easy to follow and build the microcontroller. Now, software installation and setup. This should be actually the first step to do. So very important, you need to download and install the Arduino programming environment. So here we're gonna look at only the Arduino, by the way, but you can actually, depending on your school, you can use any of the other two programming environments. So you need to download and install the Arduino programming environment, Arduino IDE. You need to go to this website here, arduino.cc main software, and download the Arduino environment that is suitable for your system. If you have Mac, you download for Mac. If you have Windows, you download it for Windows. After that, after you download it and install it, you need to install the CoDrone library. So this, by the way, is actually object-oriented. This C++ is, of course, an object-oriented programming language. It uses objects. And let's say you explain it easier in an easier way. So it basically uses libraries. Just like imagine you have a library and you have books in it, shelves. So you can go to a library, open, for example, go to the shelf and get a book, for example. The same thing here. So you can go to a library and get an object from there. So that's why we need to install the CoDrone library, because we're going to use the functions in that library. And please follow the instructions here. It's very easy on Arduino, really easy. Basically, you click on Sketch, then include library. By the way, a program in Arduino is called a sketch. Okay, so when you hear the word sketch, that means we're talking about a program, a code. So include library, manage libraries, and you download the CoDrone library. Now, the third step, very important, is to install the hardware files. So please follow the instructions here. File, then preferences, if you have a Windows computer. If you have a Mac computer, then you go to you click on Arduino, then preferences. Then under additional boards manager URLs, you need to paste the following URL. So you paste this over here, you paste it there, and that will get you your hardware setup. Of course, go to tools, boards, and board manager, then change the type from all to contributed, then find the package Rocket by RoboLink and install it. So this step will get you will get the hardware and files installed. Finally, you need to install the USB drive. So you need to go to Scilabs over here and download the driver software for your operating system and run it. These, by the way, these instructions are found on the project website, nsfsmart.org. So if you want to find these links, you can just go to the project website, nsfsmart.org, and just follow the instructions. All right, now we're gonna do some programming. So after we have installed these files and after we have built the controller on for the CoDrone. By the way, actually you have the website for the manufacturer also contains all the information that I mentioned. Everything in detail, super detailed really, can be found on the manufacturer website. So Now here we're going to program with Arduino, like I mentioned. Every Arduino program must have two functions. There's two functions that must be included in every Arduino program. The void setup, okay? The void setup and the void loop function. Now, the word void means it doesn't return anything. It's not expecting to return anything when it's executed. So you need to include braces, as you see, after every function. You know, you have to include braces. You leave these empty, by the way, the parentheses. You leave them empty because you're not expect it's not going to return to you anything. So the setup. So only executes. So any code that is written here between these two braces inside the setup function only executes once. Now the void loop function, the code in between these two parentheses repeats continuously. Okay. As a start, use the list of functions shown in the handout to write a program that does the following. So let's, for example, look at this here. Set pins 11, 12, and 18 as outputs. Turn LEDs 11, 12, and 18 on. Then turn off LEDs 11, LED 11 after 500 milliseconds. Turn off LED 12 after 500 milliseconds. Then turn off LED 18 after 500 milliseconds. And repeat the sequence. So this is going to be the program. This is going to be our first example. We're going to write a program or a sketch that and program the CoDrone to execute this program. So something very important here. We need to include. You need to use this called a directive. Okay, when you put so when you put this, so when you have include this CoDrone.h, this is called directive. Okay, so you can actually look at, for example, a list of CoDrone functions. You can actually find them really easily on the manufacturer website. So when you include a library, then only then you can use the functions that are inside that library. Okay, so this has to be the first. So this has to be the first line of code for you. The pound sign, include, then you put the name of the library between these two marks. Setup procedure: the communication speed is first set to a baud rate of 115,200 bits per second. So this is one of the first things that we need to do, is to set up the baud rate. The baud rate means the communication speed. Okay, it's a serial communication, so it's going to send bit by bit, right? So so the speed of communication is going to be 115,200 bits per second. Now this is the speed of communication for the Bluetooth, by the way. It's a standard speed. So this is done by using the begin function member as follows. So CoDrone.begin. So as you see here, this is the reason why it's called object-oriented programming. So the name of the library is CoDrone. You see, we included the library CoDrone. So CoDrone.begin, you're going to use the begin function of the library CoDrone, and it takes an input parameter here, which is going to be the speed of communication. The pair function is used to pair the remote to the first recognized drone. So for example, CoDrone.pair, here if you leave the parentheses empty, then it's going to search. It's going to search for drones around it, and it's going to, the first one it sees is going to connect to it. Okay, so this is actually very important when you actually in your classroom, for example, when you use the drones, it's actually recommended to tell the students first to be apart, very far from each other, okay, and to turn on their drones one after another. So first you pair, so the first student, for example, pairs his or her remote controller with his or her drone. Then after that student finishes, the next student starts, and so on. And you keep them far away from each other, because the reason why, because it's gonna search for the drones around, and it's gonna, the first one it detects is gonna be the one that it communicates with. By the way, actually, you can add, there is actually a parameter, the parameter nearest. If you put, for example, nearest, pair with the nearest drone, is gonna only pair with the one that has the strongest signal. Okay. Other functions may be used, such as takeoff, hover, land, and other functions, as you can see in the manufacturer website. So this is the example to write a program that makes the drone take off, hover for 6 seconds, and then land. So let's do this program here. So the first line of code that we need to include is include. So we have the pound sign, include, CoDrone, then the greater and the smaller than signs. In between them, you put CoDrone.h. Again, this here is a directive. It's not a command. It's a directive that tells the programming environment to include this library in the program, because we're going to use its functions. Okay. Now here we have void setup. Remember, this function must be included in every single program. Void setup, and inside its braces, we're going to put this code over here. CoDrone.begin. Something that is very important. These are, of course, C++ is case sensitive. If you, for example, if you use, for example, a small case when it's supposed to be an uppercase, it's going to give you an error. Okay, so make sure you include the correct form of the letters. Okay, whether uppercase or lowercase. CoDrone.begin. 1050, 100, 200 bits per second. In other words, this is going to be the baud rate of communication. CoDrone.pair is gonna pair with the first drone it finds. Any drone it finds, the first one it finds is gonna pair with it. Okay, that's why it's very important. Again, you need to make sure that when you actually start the program, you run it, when you turn it on, make sure that you're actually far away from others, or you're gonna actually it happens a lot that you're gonna actually pair with someone else's drone, or someone pairs with your own drone. Okay, CoDrone.takeoff. This is the function for takeoff. CoDrone.hover for 3 seconds. It takes as an input the number of seconds that you want, and then CoDrone.land. It will land. So it's going to execute this only once. As you see, it's going to do this. It's gonna take off, hover for 3 seconds, and then it's going to land, and then it's going to stop. Why? Because we put all of these inside the setup function and not inside the loop. Okay, so again here, I don't know if you can see this, the note over here. So if you take the input, the argument nearest inside the CoDrone.pair, then what's going to happen is going to search for the one that has the strongest signal. Okay, not the first, but it's going to search. It's going to connect to the drone that has the strongest signal. In other words, the one that is closest to it. All right. So after you run that program, let's do this, for example, here. Next, we are going to code for a 3-step program for the drone. The drone will connect, take off, hover for 3 seconds, and land. And this is actually the one that we just saw. So everything is in the setup function. Now let's look at lab number 1. Set up the controller pins 11, 14, and 18 as inputs. When controller pin is 18 is activated, the drone will take off, wait 2 seconds, and then land. If controller pins 11, 14, and 18 are pressed simultaneously, then emergency stop is activated. Okay, so again, let's look at it here. So we have controller, when the pin number 18 is activated, the drone will take off. It will wait for 2 seconds and then land. Okay, if at any time pins 11, 14, and 18 are pressed simultaneously, then emergency stop is activated. So the first thing we need to do, we need to set up pins 11, 14 and 18 as inputs, right? Again, remember these pins, they can be inputs or outputs, all right? You can set them up as inputs or outputs. So then after that, you can write the program. So here's the program. I wrote it for you. So of course, the first thing you have to include the directive CoDrone. You need to tell the environment that you're gonna use functions in the CoDrone library. In the setup, of course, the baud rate, we get the pairing of the drone with the controller. Then in the loop, so this is because it has to repeat continuously, right? So in the loop, byte, this is the data type, BT8. So we have now a variable BT8. Okay, now BT8 is equal to digital read. This is actually a command in Arduino. Digital read pin number 18. In other words, it's going to read digital. It's going to read pin number 18. The same thing for pin 14 and the same thing for pin 11. Once pin 18 is triggered, do a takeoff, wait 2 seconds, and then land. By the way, this here is actually for comments. Okay, so if you have these forward slashes, these are for comments. So if BT8 open braces CoDrone.takeoff and then CoDrone.land. Else if BT1 and so when you add these two and that means it's actually an and statement. Okay, if something, a condition and a condition and a condition all happen together. So here we have BT1 and BT4. In other words, if it's true, if BT1 is true, if BT4 is true, that's in other words they are activated, and not BT8. In other words, BT8 should not be activated. Here, this is the not. So the not, in other words, is 0, the exclamation point. Then what happens? CoDrone.emergency stop. This is a function called emergency stop, and we are done. All right, thank you, and let me know please if you have any questions. Thank you.